Free response problem number 5. We have a twice differentiable function, which simply means that it's a function that you can take first and second derivative of. It's defined only on a set interval from negative 1.2 to 3.2. F of 1 when x is 1 on the f function, and remember, this is the graph of first derivative, okay? This is not the graph of f. F of 1 is 2, and the graph of the first derivative is shown. The graph of the first derivative crosses the x-axis at x equal to negative 1 and x equal to 3. So we know that negative 1 and 3 are critical numbers of f. The first derivative has a horizontal tangent at x equal to 2. Let g, which is a new function, be defined as g of x is equal to e raised to the f of x. Now that's a lot of information, and you have to kind of take your time and work your way through it. But when you start looking at the questions, what you should notice is that every question is about the function g. Now this is not the first derivative of g, it's the first derivative of f. That's very, very important to understand. G is defined as a function that uses f of x. So let's see what we're going to do here. Write an equation for the line tangent to the graph of g at x equal to 1. Well, that's not too bad. We know that the equation of a line is y minus y1 equal to m times x minus x1. So we already are given an x value of 1, so we can substitute that in. The question is, what is the y value that goes along with the x value, and what is the slope that goes along with that? So in other words, we know that x is 1. We need to find g of 1. We need the y value. To find g of 1, we're going to have to come back into the function. G of 1 is equal to e to the f of 1. So how in the world am I going to find e to the f of 1? Well, good news. They told me that f of 1 is 2, so that's the same thing as e squared. So you can see down here in my work that I know that g of 1 is e squared. So every point that you can gain for yourself is a good one. Now I need to find the slope, which means I need to find the derivative of the g function. Well, the derivative of the g function is going to use the chain rule. It's the derivative of the outside, e to the u, du. So I get e to the f of x times f prime of x. So the derivative at 1 would be e to the f of 1, which we already know to be e squared, times f prime at 1. Well, up here, this is the graph, the derivative of f, so f prime at 1 is negative 4, and that's where I got that value from. So now I know the slope, and I can substitute it in place of m. So that's really not that challenging of a problem if you think about it and take your time. Part B, find all values of x at which g has a local maximum. So we're looking for local maximums of g. Well, that means we need to know, first of all, where is g prime? Where is the derivative of g equal to 0? So that's job number 1. I already know from my work in the last problem that g prime of x by the chain rule is e to the u du. And I also know that e to any power is always positive. So at least this part of the derivative is always positive. So the derivative of g only changes from negative to positive when the first derivative, because g's derivative depends on the derivative of f, and since e to the f of x is always positive, then whenever f of x, the first derivative of f, changes from negative to positive, that means that g also changes from negative to positive. So I'm going to go back up to the first derivative of f graph, and I can see that the first derivative of f changes from negative to positive. Okay, I'm seeing a mistake in my work. At x equal to 3, and is g of 3 because I can see that the first derivative changes from negative to positive at 3. So I did have a mistake in my work, and now that has been corrected. Letter C. The second derivative of g is given as what we see. Is the second derivative at -1 positive, negative, or 0? Justify your answer. Well, I'm going to substitute -1 in place of all the x's. And again, we know that e to any power is gives me a positive outcome. The first derivative, and again, I'm just substituting into their problem. The first derivative at -1 squared, the first derivative at -1 from the graph we can see is 0. And 0 squared is 0. The second derivative at -1, if you look at the graph, let me erase this. If you look at the graph of -1, we're concerned about the second derivative. You can see that the slope at -1, which is the second derivative, the slope is negative. Therefore, the second derivative at -1 is negative. So I have 0 plus a negative. So here's my positive outcome. So I have a positive. 0 plus a negative is a negative, and a positive times a negative is a negative. Therefore, the outcome, or g second derivative at -1, is negative, and my work verifies that. And then finally, letter D, find the average rate of change. Average rate of change is ARC, which tells me I need to find simple slope. The average rate of change of the first derivative of g over the interval from 1 to 3. So average rate of change tells me slope, and so I have an x value of 1. I need the derivative of g at 1. I have an x value of 3, and I need the first derivative of g at 3. So the average rate, so the first thing I'm going to do, I already know that when x is 1, the first derivative is -4e squared. I did that back up here. And then I need to find the first derivative at 3, g of 3. So I'm going to go to my first derivative, substitute 3. So since the first derivative at 3 of f is 0, 0 times whatever that is, even though I don't know what it is, 0 times that number will give me 0. So I have these 2 points that I'm working with are my x and y values. So I'm going to do change in y over change in x and simplify, and that will give me the average rate of change, or the slope. Now again, these problems are not extremely difficult. You just have to take your time and not give up on the problem. Because as you can see, like in this part right here, even though I don't know what e raised to the f of 3 is, it doesn't matter, because when I multiply it by 0, I can still get an outcome that I can work with.